Chapter 3 Universe in Search of Roots. I, however, believe that there is at least one philosophical problem in which all thinking humans are interested. It is the problem of cosmology, the problem of understanding the world, including ourselves and our knowledge as part of the world. All science is cosmology, I believe, and for me, the interest of philosophy, no less than of science, lies solely in the contributions which it has made to it. K.R. Popper. We're fascinated by the universe due to its immense vastness and distances between celestial bodies, its fantastic age, our inability to understand its creation, and open questions about its future. Its manifested simplicity and complicity, its simultaneous definiteness and extreme ambiguity puzzle us. We ask ourselves, does the universe include everything that has ever existed and that will ever exist? Is the universe eternal and indestructible? What is the universe made of? Does it change? Is there one universe or an indefinite multitude of universes? Is one universe nested into another one? The answers are difficult to find, but the following is obvious. The universe represents one of the biggest secrets, and we do not know whether humans will ever be able to solve it. It was Albert Einstein, 1879 to 1955, who said that the greatest mysteries are the existence of universe and its intelligence. And J.A. Willard asked, how was the universe conceived? Understanding that a significant part of the answer lies in the way the question is asked. To wit, maybe the right question can only be asked if we know the answer. And is there an answer at all? Is the mystery of creation beyond our understanding forever? Is a cosmological ignorance different from other types of ignorance because it exceeds them? That's to say, encompasses all other types of ignorance. Can it be deduced that the particularity of the universe is determined by our participation in cosmic events? In other words, is this participation the most peculiar feature of the universe, but also our most important connection to the universe? Is the moment of our existence determined by the ability to participate, even just as spectator of the universe? Does the universe exist only if it can be observed? Is then observation the basic principle and the source of all laws of physics? Are all laws of time and space based on that? Chapter 3.1 The Origin of the Universe and Its Characteristics. Even if they don't give the answers, it's important to ask questions. J. Gardner. The universe was formed 15 to 20 billion years ago from an amorphous mass, the particles of which had a high entropy. The mass was galvanized into action by the Big Bang and expanded in space together with all-encompassing microwave radiation. We do not know what was before the Big Bang, if anything existed at that time, or the reason of its occurrence. The force that moved it and which made cosmos out of chaos was probably the most fantastic transformation of the matter and energy, one that we can hardly imagine. Before the Big Bang, the matter and energy were probably concentrated in a cosmic egg or in a dimensionless mathematical point with immense density temperature, and pressure, where the space-time structure was subdued in absolute singularity. Still, new questions and dilemmas arise from such assumptions. In the beginning, was there chaos, a state of extreme inhomogeneity and anisotropy, which aims towards absolute order, homogeneity, and isotropy? Or the situation was reversed, absolute order burst into chaos? Was the cosmic egg homogeneous, or was it content lumpy? Was the Big Bang one explosion, or did it consist of several simultaneous ones? Was it initiated by a supernatural creator? Did the creator determine the initial events and then allowed for the universe to continue developing on its own? How and why did the creator choose certain possibilities of initial events? This is why Einstein said, "What really interests me is whether God had a choice in the creation of the world. Is the space-time structure finite, but at the same time without boundaries, without a beginning or an end? Was the universe conceived as infinitely dense in the singularity of the Big Bang, but in this singularity there was no place for any laws of physics, so it was impossible to foresee the consequences?" Many civilizations created myths about the creation of the world, often comparing the occurrences in the universe with changes in the biological world. Therefore, they spoke about the birth, the growth, and the death of the universe. It is a magnificent idea about a constant permeation of human experience and cosmic forces, which demonstrates the unity of all that exists. This audacious thought deserves our respect. Many religions glorify it, artists describe it, and philosophy and science keep verifying it. At the moment of the Big Bang, all that existed had to be of unmeasurable density and composed of photons, light. The heat was extreme. This calls to mind the verses from Genesis according to which light was the first creation. And God said, "Let there be light." Scientists, philosophers, artists have been trying to apprehend the universe and the dynamics of its development in time. They research its past, present, and future. For instance, Herbert Spencer, 1820 to 1903, proposed an evolutionary theory of the creation of the universe, emphasizing uninterrupted movement from an incoherent, undetermined, and heterogeneous state to a more coherent, determined, and homogeneous form. His determinist, materialist, and mechanicist concept allows the possibility of even more pronounced differentiation and integration of different cosmic factors into more complex aggregations. The immeasurable size and the magnificent anatomy of the universe were scientifically understood only in the 20th century. This novelty was enabled by significant advances in science and mechanics, which replaced the study of the universe by simple observation only. We are no longer interested in a mechanicist view of the universe. Up until 100 years ago, our predecessors imagined it as a large mechanism composed of objects which formed independently and were subsequently, in an artificial manner, harmonized with outer forces. While they perceived the universe mostly as a static and unchangeable complex, we perceive it today as a large organism which has already gone through different phases of development and has an infinite future ahead of it. Many factors within the universe are interrelated. Beings are gradually appearing and constantly changing on the stage of history. Chapter 3.2 Galactic Explosions. These are the most intense events in the universe. Since I include the Big Bang in this category, they are a paradigm of the fantastic power of universal forces of an incredible extent. We often proudly say we are in a position to speculate with a great level of accuracy about what happened as of 0.01 seconds after the Big Bang. The events during the Big Bang are mathematically described by the equations of Einstein's theory of general relativity. However, the accepted Big Bang module includes the view that in the beginning there was singularity and that temperature and density were infinite. In such circumstances of extreme conditions, Einstein's equations do not apply. Therefore, in order for us to further understand the universe, above all its creation but also its expansion, we must elaborate new modules and theories such as quantum gravity. Namely, the existence of singularity at the very beginning of the universe has opened unresolved dilemmas about the characteristics of space and time at the moment of creation. We, the humans, perceive space and time as essentially different notions since we live billions of years after the Big Bang and in the world of low energies. Were physical principles in the period of the early universe as they are today, regardless of the fact that we consider reasonably, but who can claim that this is correct, that physical laws after the formation of the universe remain mostly the same, these laws are not believed to have been the same at the moment of creation as they are today. For instance, the closer we are to the Big Bang, the more electromagnetic forces and weak interaction forces change. As a result, it is impossible to distinguish between them at extremely high temperatures. Is it not that in the relativity theory, space and time form a four-dimensional system in which three spatial and one temporal dimensions are unified? However, Jim Hartle and Stephen Hawking consider that time loses its characteristics in very strong gravitational fields. Thus, space-time loses its constraints, and consequently, there is no beginning. The Big Bang cannot occur. There is no singularity because there is no time. I consider it logical to ask, were there any physical laws before the physical universe? Is the universe mathematical, so it can be interpreted in a mathematical manner? And finally, can the universe be understood logically, since in its foundations, if there are any at all, maybe there are no principles that can be perceived by the logic? At the moment of the Big Bang, the temperature was 10 to the power of 11 K, and the universe was brightly lit. From a large quantity of matter and antimatter, which were present in approximately the same amount, a large mass of electrons, positrons, and neutrinos was probably formed with a density of 4 times 10 to the power of 12 kg per cubic meter. Neutrons and protons were also formed, but in a 10 to the power of 9 times lower quantity. Due to an abrupt explosion, within 14 seconds, the temperature fell to 3 times 10 to the ninth power K. Protons and neutrons kept being formed, but the latter to a lesser extent. Electrons and positrons were annihilated and photons were formed. About 3.5 minutes after the Big Bang, positrons and electrons were mostly annihilated. Quantity of photons was 10 to the ninth power times higher than that of nuclear particles, the quantity of protons 6 times higher than that of neutrons, and etc. The temperature cooled down enough for the protons and neutrons to be torn off from the efforts of strong nuclear forces. Consequently, they began to connect, and the coupling of one neutron and one proton gave rise to deuterium. Since protons are nuclei of hydrogen atoms and deuterium enriched by a neutron and a proton forms a nucleus of helium atoms, we consider that during several minutes after the Big Bang, hydrogen and helium were formed. In these several minutes, basic matter of the universe was formed, which is even today composed of 99% of hydrogen and helium. Other elements were formed later by cooking of the universe. As of several hours after the Big Bang and during the next 300,000 years, the universe was an opaque mass of expanding gas. The name blazing world of darkness suits it well. It was dominated by electrons, hydrogen, and helium nuclei, and a multitude of photons. Due to a sudden explosion, this gaseous mass was cooling quickly. When the temperature of the universe dropped below 3000 K, electrons had no more energy to resist the electromagnetic attraction of nuclei. And consequently, numerous atoms of hydrogen, helium, and other elements were formed, and the universe was gradually clearing. Soon it became transparent again. The universe kept expanding and cooling down, and in the areas which were denser than the average, the expansion was slowed down by the forces of gravitational compression. In some areas, they were even strong enough to cause the collapse of recently formed matter. As a consequence, changes of gravitational attraction in different areas of the universe prompted the gases and the solid matter to start to rotate. The universe we see today is a mass connected in about 200 billion galaxies separated by vast free spaces. Particles are very rare in interstellar space. There is one molecule of gas per 15 to 16 cubic centimeter. Planets are even rarer and thus valuable. If we were to be thrown to the universe, a chance to meet any planet would be 1 to 10 to the power of 33rd. The temperature of universal radiation at present time is 2.726 K, and darkness, for example, an invisible matter dominating gravitational events, prevails. The notion of cold dark matter is often used. All the above mentioned opens a new set of questions. Why does the universe have a temperature? Why 2.726 K exactly? Where did the vacuum in the universe come from? Why 2 times 10 to the minus 31st power of the atom exactly? What are further characteristics of the cold dark matter? And similar.